Okay, so if we are solving rational equations, that means we're going to see equal signs. What does it mean if a rational is equal? For instance, if I give you 1/2, what's equal to 1/2? A half. How do you know that? Because the what's the same? So we have to have equal numerator and denominator. Because rational is what we use for fractions when we have expressions. That's what it means when they're equal. They have equal numerators, and denominators. Sounds weird when you say it like that. Okay, so these four right here are really basic equations to solve. We're using that concept. If the numerators are the same, then the denominators have to be the same, or vice versa. So if you look at the first example, what's the same already? The 2's. So do I have to worry about 2 equaling 2? No, but the denominator right here is missing. What would it have to be to make this true? 10. There you go. You solved it. X equals 10. Does that make sense? Does 2 over 10 equal 2 over 10? Yeah. So did I solve for the x value? That makes it true. Yeah. That's what it would be. You're solving for the variable that makes the equation true. Okay, so on the next one, we know the 4's are the same. And what do you say, Julie? K would have to be 3 to make it true. So this is very simple. That's just to get you guys to understand what I'm talking about with having equivalent rationals. So this one's a little different. 2 is not the same as 4, and y is not the same as y squared. But we know that first, we usually find common denominators. How could I get this denominator to be the same as this one? Multiply it by some factor. What factor is missing? Y. Another y. So if I multiply the denominator by y, I have to multiply the numerator by y. Okay, let's rewrite what this equation says now. We have 2y over y squared equals 4 over y squared. So do I need to worry about the denominators being equal? No, because I could have had any y value. Any y value you plug in, they're exactly the same expression. But are the numerators the same? Can we solve for what would make it true, though? Yeah. Yes, so I set the 2y equal to what? What does 2y have to be? It has to be 4, so how do I solve for y? Divide by 2, and we get y equals 2. And if you wanted to verify that, plug it in. What is 2 divided by 2? 1. And if I plug it in here, well, 2 squared is 4. 4 divided by 4 is also 1. It makes it true. You're finding the variable that makes sense. All right, the next one, a little bit different because now we got fractions adding, and the sum of these is equal to 11 over 12. So can I just say x plus 1 equals 11? What should I do first if I'm trying to compare it to the other one? Get the same denominator and then compare it. So let's add these fractions. How can I make the same denominator? Is 6 missing a factor that gives me 3? Is 3 missing a factor that could give me 6? 2. So let's multiply 3 by 2 and 1 by 2. And we rewrite x over 6 plus 2 over 6. And those are supposed to add to give me 11 over 12. Does that make sense? Is 6 plus 6 12? Yeah. Because we add denominators? No, we keep the same denominator, so do not do that. I could add my numerators, x plus 2, over the same denominator, and we say that that has to equal what? Now we're back in the same position as we were with this one. We compare them. Well, 6 is not the same as 12, but we can find a common denominator to where they're equal. What could I do? Huh? Which one? Yep, multiply the 6 by 2, which means we multiply the x plus 2 by 2. And then when I rewrite, we get 2 times x is 2 times 2 is 4 all over 12. So now, do we have to worry about the denominators being equal? So since the denominators are equal, we assume that the numerators are equal. So let's take that the equation in the numerators, The 2x plus 4 equals 11, and we solve that. Any question right now before we solve it? Okay, so we go off to the side. 2x plus 4 equals 11. Cover up the 11. Furthest thing from the x is the
2x is 4.
4, so I need to... Okay, bring down your 2x. 11 minus 4 is close. Oh, wait, sorry, yeah, 7. I was thinking negative 7. And last step, cover up the 7, and 2 is attached, meaning it's multiplying. How do I get rid of the 2? Divide by 2. Oh my gosh, we get a fraction. Did we do it wrong? No, you could get fractions and decimals. There's nothing wrong with that. So what this means is if I were to have taken the 7 over 2 and plugged it in for x, it should make a true statement. Questions? All right. So just to recap the 3 steps really quickly, same as always, when we look at denominators, we want to make sure that we factor them. So always factor where possible your denominators. And then we want to look for common denominators. And once we find a common denominator, what am I solving? The equation in the what? Think back. Once we get that common denominator, when they're equal, where's the equation at that we're solving? In the numerator. Because you already know the denominator is equal, so you assume the numerators are equal.